Thank you very much for the nice introduction. As Lettuce was saying, my name is Suzanne, and I was here yesterday talking about some of the trends in spatial data science, but in this session today, we're going to be focusing on real time, which is not something we covered in depth yesterday. Pardon me. So we're going to get started just talking about some of the typical use cases for real-time geospatial data. Some of these may be familiar to you guys already if you're using these technologies or you're facing these kinds of problems in your jobs. Given that about, I think, 80 to 90% of sensor data has a location component, at least that's what gets estimated by like Gartner and whatnot. There's really a lot of use cases that lend themselves to real-time geospatial location needs. One example, kind of starting here on the top left, is employee tracking and personnel tracking. So a lot of organizations these days are interested in tracking information about employee locations. That information sometimes comes from your phone. You might have an app on your phone that you've opted into, and it's tracking your location in such a way that it becomes accessible to your company. We have a variety of customers that do that. And a lot of times it's for safety reasons. It's not to be big brother, but it's about knowing where field crews are so that you can alert them about dangerous events around them, or so that over time you can look at efficiency and optimize your field crews. And these use cases also basically, if we start to go over to the middle of the top row, it also gets into general resource optimization. So people are tracking employees, but they're also tracking their vehicles and their assets. That's been going on even longer than employee tracking, of course. And we talked a little bit about that yesterday if you were here for the keynote. And again, usually with the resource optimization workflows, it's usually about collecting that data in real time and potentially making certain decisions in real time, but also collecting that information over time and being able to understand where time is being lost in field inspections or other types of field activities. And then many organizations want to be able to leverage real-time contextual information to protect critical infrastructure. So you might have, a utility network, looking after its power lines or its junction boxes and things of that nature out in the field. And historically, these use cases tended to be around protecting from weather or natural disasters, but there's an increasing variety of real-time information out there from different providers these days. So threat monitoring can really depend in terms of what you're monitoring, depending on the sector. And then coming down here on the bottom, there's also use cases that are particular to certain types of industries. So in the utility space, there's SCADA integration and operations monitoring. In the agricultural and environmental markets, there's increased usage of sensors out in the fields to do crop monitoring or air quality monitoring. And a lot of local governments are increasingly beginning to deploy sensors on the roadway networks to collect information from connected cars and really begin to understand and analyze traffic at micro patterns more so than ever before. And so with ArcGIS, there's a lot of different capabilities within the platform in general that support these use cases across data ingestion, monitoring, analysis, and situational awareness. So on the one hand, ArcGIS enables you to connect to data from external systems and bring that in a streaming way. You can also certainly monitor data that's already getting into feature layers, but there's capabilities that can kind of sit on the edge of your GIS implementation and bring in data from IoT systems, from external data vendors and so forth. And it also supports data management of that information over time as it grows into large collections of data. Analysis-wise, there's streaming server-side real-time analytics in ArcGIS. We're going to actually focus on that probably the most today. But there's also a variety of ways to do scheduled analytics in ArcGIS so that you can be amassing data and then running a certain type of analysis on a schedule so you can create information products that are always up to date. Visualization of data in real time is all about driving new information to the map so that the user can see that something's changed. And this is supported in ArcGIS with capabilities as simple as layer refresh in web maps, but also with streaming feature layers. And then there's also ready-to-use content that's relatively real-time in nature. So in the Living Atlas, we have a section of data sets that we refer to as live feeds. And that includes various things like active wildfires in the US and other things that you can just use and bring into your maps and applications. And then lastly, alerting and collaboration is kind of a fifth main capability need typically involved in real-time workflows. Typically, you do something in real time because you want to take an action in real time. If you're not just databasing data, it's because you want to take some sort of action. And so that's where the alerting and the collaboration comes in. And this can happen through sending email or text notifications to users when certain conditions occur, but it can also include triggering an action in an external business system or an action elsewhere in ArcGIS. So we're going to dig into all of that. And these capabilities, I'm talking about them very generally here, but they're found in different places in different ArcGIS products, depending on what use case you have. So there's some capabilities in our field applications that really have to do with enabling field real-time workflows. But all of these sort of 5 sort of sectors of capability are available within ArcGIS Velocity and GeoEvent Server as server-side configurable capabilities. So with that, basically, Velocity and GeoEvent have all these different configurations for all of these that you can basically adapt as needed to your use case. They're very agnostic in that way. And as server-side technology, they also support higher velocities of data than what you might experience if, for example, you were building a client-side app to connect to real-time data and you were doing everything on the client. So primarily, we differentiate Velocity and GeoEvent to customers based on sort of the logistics of what you need for your real-time use cases. Velocity is software as a service, so it's available through ArcGIS Online, and as such, it requires less configuration and maintenance. And GeoEvent is a server role for ArcGIS Enterprise. So neither of them run just, as a desktop application. They are on the server, and they have some slight differences between them in terms of functionality, but for the most part, they offer the same capabilities and they allow you to configure the same sorts of use cases that we just talked about. So with the rest of this session, what I'm going to do is talk about each of these 5 things, sort of not actually in this order. I lied to you here. It's not in this order on this slide, but we're going to go through each of these to sort of talk about how you can configure some of this with a few examples. All right, so we'll get started with bringing in real-time data into ArcGIS and how that can work, specifically with both Velocity and GeoEvent. Keep hitting the right-click mouse. My apologies. All right, so broadly, you can use either ArcGIS Velocity or GeoEvent Server to connect to and ingest real-time data from external systems. And so a lot of times we see customers using these products to bring in AVL tracks from their vehicles and their fleets. But this could also be asset tracks, but from individuals that's collected in different ways. I know we just talked about in a lot of ways now, if you're tracking people, you might be pulling that data in from their cell phone. But there's also some customers we work with that have wearable devices that are tracking information. So if you think about the body cams that police officers are increasingly wearing, a lot of those also collect location information. And so there's different types of tracks that these products can be used to bring in data from besides just vehicles, if you will. There's also data streams out there in the market that have to do with transport and shipping and logistics. So we have lots of customers that work with AIS maritime shipping data, and they monitor maritime vessels that may be carrying their goods, from supplier to customer. These products can also be able to bring in sensor and IoT observations. And I say sensor and IoT a lot. IoT, of course, means Internet of Things. And you really could probably classify everything above sensor and IoT observations on this slide as a type of sensor observation. But usually when people say Internet of Things sensors, they're referring to stationary sensors that might be in a fixed spot, and they might be bringing in information on temperature or on wind speed, some sort of environmental reading in a lot of cases. Or a lot of other Internet of Things deployments have to do with roadways and, what's the temperature of the roadway, what's the, vibration on the roadway or on the bridge. So there's a lot of infrastructure monitoring that goes along with IoT data as well. And then another category of data that these products can bring in is this last one, which is incidents and threats. And usually we use this term to refer to kind of point in time data, like where it's an incident that just happens and it's not a track that is moving, or it's not a fixed sensor that's constantly producing data, but it's just something that's happened in some way. So, or reported in some way. So an easy example of that might be a traffic event from Waze. Like you might be monitoring data from Waze, and there's regular information from Waze on the, speed and the traffic jams on the street level, but you might also get, oh, there's a police man here, there's an accident here, there's a slowdown here, and those come in as discrete events in a lot of cases. Another example of incidents and threats might be crime data. We have some customers that use something called ShotSpotter, which some of you may have heard of, and it actually is an audio system that can detect gunshots. And it is one of those things that'll just produce, data and say, we think we triangulated and heard a gunshot in this general region. And that would be another example of a point in time event, if you will. So all of this to say that generally you can bring in almost any kind of real-time data with these products. I will caveat that and say that it's typically real-time data that is tabular or vector in some way. These particular products aren't for streaming video or images coming in real time. At least they don't parse those things and work with those things. And we do have other technology that does that. But Velocity and GeoEvent both take an approach of configurable connectors for bringing in real-time data. So they support different data transfer protocols and different formats of information. And the whole point is basically to make things converted into features so that you can use them in ArcGIS. So these are the configurable inputs and outputs and formats. Specifically, these are the supported items for Velocity. The story for GeoEvent is very similar. The approach, again, with ArcGIS technology is not necessarily building connectors for specific data providers one by one. Instead, we take an approach of supporting standard data transfer paradigms like HTTP, like WebSockets, like common message brokers that have been used for years with real-time technology like Kafka and RabbitMQ. And using these base connectors, you can configure the right way to talk to any of your data providers or your business systems. So for example, MQTT can be used as a bridge to bring in vehicle tracking data from an AVL vendor that you might have, or an Azure or AWS Event Hub might be something that you would use as a bridge to bring in data from a SCADA system and so forth. And again, the goal is to get your data usable in ArcGIS in most cases. That's what a lot of our customers tend to use these for, as opposed to just doing some sort of incident detection and then sending the results elsewhere. It's usually about getting the data into ArcGIS so that you can visualize it and use it for situational awareness. All right, so what we're going to do now is take a look at an example of bringing in some data, again, in real time. And in this case, the data that we're going to bring in is passive drone detection data from a business partner that we have called Hidden Level. So just a little bit of background about Hidden Level. Their offerings are really all in the space of airspace monitoring. So in their words, what they're all about is alleviating the burden for customers in terms of keeping up with drone technology and detecting drones in their customer spaces. This is not a commercial, just giving you guys context. The way Hidden Level's technology works is that it gets installed in existing infrastructure in various jurisdictions. So you can see a picture here of their equipment is installed on the one hand on a cell tower, in the image on the right on top of a building, where presumably they were able to get permission to install. And their equipment is increasingly installed in various places across the US. They're a growing company. I think they have installations in 7 states at this point. And what this does is enable them to provide really broad coverage of active drone flights. Even if, the drone flyers, have no knowledge of, their activities being monitored, this equipment can pick up drones and get readings off the drone. And we'll see what that looks like. And as you can imagine, this kind of information is really useful and interesting to a lot of customers. It's interesting, for example, to local governments who want to understand if drones are intruding into no-fly areas or if they're flying too low and violating privacy rules. This data is interesting even to private companies who want to make sure that their facilities aren't being monitored by competitors, and so on. All right, so let's go ahead and get this going. So we're starting out here in the Velocity web application, and this is where you can configure different real-time services. And to configure a feed, we can go over to the feed section. And because I'm in ArcGIS, there's the ability to create a feed from sources you'd probably expect. So on the left, like feature layers and stream layers. If you already have data that's coming into ArcGIS in real time in some way, you can use this to be able to access that data for real-time analytics. Or if you want to consume data from an Azure or AWS Event Hub, you can do that. And we also do have some direct support for particular types of data providers that we often see. Right now, it's mainly AVL providers, so Verizon and Geotab. But this section of web and messaging is where a lot of the power comes from. And we like to think of these as the different kinds of pipes that your vendors or your business systems may already be making data available in. So you could pull a REST API with the HTTP connectors. You could connect to something over a WebSocket, or you could connect to a message broker. Now, when you choose one of the feed types to configure, you're going to get a screen that looks a lot like this. All of these different connectors walk you through the process of putting in the pieces that you need to get to that system. So in the case of reaching out to something over REST, you would put in a URL. You can also specify, what the authentication paradigm is for connecting to that thing. Is it a certificate? Is it a username or password? Is it OAuth? And so forth. And I'll go ahead and keep this moving here. In the case of hidden level, their data is made available over a WebSocket. So we're going to switch over to the WebSocket connector as soon as I get my mouse back. And we're going to skip over the step of putting in the connection information just because that would expose the API key that we have for hidden level. And we don't want you guys having our API key. But once you put in the initial connection details for a particular external system, Velocity samples the data, and then it basically is able to derive the schema for you and attempt to guess the fields and the types of that data that's flowing. So we're going to get to that next here. If it keeps up with me. So this data from hidden level is JSON data. And the way that you navigate through this in this feed wizard is that you can basically put in different things to keep parsing the data down to the levels that you want. A lot of JSON data is very nested. So for example, here, I just see the two top level objects, but if I want to get at all the data inside this track object, I can put that in as the root node and I can rederive the schema. So that kind of breaks that out. And now you see all the individual fields in the data. And with this data, there's also some arrays in the data. So we can flatten arrays and continue to break out attributes into separate things so that we can work with them as fields in ArcGIS. And once you've got the schema set up the way you want it, you have to put in a couple key properties. So there's first the location. And you might be saying, well, I'm in ArcGIS, doesn't everything have location? But actually a lot of sensor data, again, those fixed sensors often report data without coordinates because they're always in the same place. So if you have data like that, you can always join in geometry later from based on a join attribute in an analytic. Now, in this case, the drone data does come with coordinates, so you can choose to set up your location based on X, Y fields in the data. We didn't rename these fields with super helpful names, but these are the two fields that provide the X and Y information. And then the other thing that we can do is set the altitude of the drone. And we know that that altitude is expressed in meters, so we can configure that. And of course, in a lot of cases, when you're getting data with XY coordinates, the information is coming in WGS 1984, so you can set the spatial coordinate reference system there. Now, another important thing to set up is the date and time information. Real-time data, it's very important to be able to recognize the time and the date information that's inherent in the data. So you can select what field that's coming from as well. This data in this case has a lot of fields, so bear with me here. In this case, it pops up an example value of that date time information to the side so that you can see from that data provider how they formatted the data information. And you can specify a formatter within this screen so that you can properly parse that because everybody does it differently. People like to say that there's a standard, but everybody's standard seems to be their own. And then the last thing here is to specify the track ID. So this is the thing that uniquely identifies each entity in the data. In this case, it would be the ID of the drone that is detected through this drone detecting equipment that Hidden Level has. So at this point, we'll be setting up this feed. We can just give it a name. We can optionally give it a summary. It's going to become another item in ArcGIS Online that can be shared. And within Velocity, you have some quick ways to assemble the data to be stored over time. So you can just toggle on that you want to store the data, and you can specify how long you want to keep that data for as it grows in real time. So in this case, we're going to set it to a year, and we're not going to set up any archiving steps, but we'll come back to the archiving later. So when you start up a feed in Velocity, it's basically publishing a hosted microservice that then is going to be running continuously and bringing in that data and processing it. And when a feed starts up, You can get a preview of it in the map that kind of comes up in the feed details page. So in this case, the drone data that we've connected to is over Dallas, Fort Worth, I think. And we're replaying some data from hidden level that we got in, and we're re-simulating that so that we had something predictable to show here. And you can also go to the metrics page and see how much data is flowing at any given time. So this data is not coming in that fast yet, but you can look at that over different time intervals. There's also access, as you might expect, to logs on a per service level so that you can kind of see what, if you are experiencing any errors reaching out to your external provider, you'll get that information here. And then any feed is able to be added to the map viewer, and you can get that real-time data being pushed to the map right away. So the feed that we just created has been added to the map, and as we get the next round of updates from the drones that are being detected, we'll see that in the map there. So we'll go back into as we get into some of the other visualization and various particulars of all this, we'll talk a little bit more about how this is happening. But the kind of fundamental here is that within at least ArcGIS Velocity, feeds are kind of this thing that encapsulates data ingestion. You have this guided wizard to set it up, to connect to your external source of information, to specify your security and authentication particulars, and then that data becomes a flowing live stream of information that can be used in ArcGIS. All right, so that's the workflow within Velocity. Admittedly, that was a Velocity demo, so I just kind of wanted to note that there are some differences in doing this with GeoEvent Server, if that's a product that you're using today or that you're interested in. In Velocity, you create this thing called a feed, and it automatically samples the data and derives the schema as we saw, and then you can just tweak it as you see fit. But within GeoEvent, you create something called an input, but on the whole, it's very much in many ways the same thing. You do some things differently, like on the side, you create a GeoEvent definition, which defines your schema, and then you associate that with your input. And you would define additional components if you actually wanted to store something. Whereas in Velocity, this is all kind of collapsed into one process. But the approaches are very much the same. All right, so next we're going to look at how to process this data as it comes in once you have it configured and actually you've connected to it with either Velocity or GeoEvent. So fundamentally, real-time analysis enables you to add value to observational data. And there's probably four main things that our customers are typically doing when they process data in real time. So the first is parsing the data for visualization. And we kind of showed a bunch of that already. A lot of that actually happens just in the setup of the connection to the thing and the defining of the schema. But there's also tools within the real-time analytics to do more, to rearrange your schema, to map fields from one name to another, to calculate new fields, or to merge different data streams into the same thing. We do sometimes work with customers that have one data stream that reports the location of their vehicles and another data stream which provides the diagnostics at any given time. And so often they want to merge that within the real-time analytics so they get one layer in the end in the GIS. So that's what I mean by kind of just utilities for parsing data. Real-time data is also often enriched with asset details. So you might be bringing in information like vehicle positions, and you might want to geo-enrich that position with which jurisdiction something's in at any given time. And so that could be just done through a join at the spatial proximity level. And you could also be joining to other static information in your environment so that you can add fields to your data and have a more complete picture when you're looking at the information in real time. Another thing that is sort of along the lines of enriching asset details is enriching geometry. So when we were setting up the feed, I spoke about how there's some data that is a fixed sensor and it doesn't necessarily come in with location. So sometimes people actually use an attribute join to add geometry into the data. So you might have a feature class of points somewhere and this real-time data with sensor observations, and you could just map that point location onto the data so that you can see it in the map. And that's something people do in the real-time analytics. But there's also geometry transformations that you can do. So for example, I have a vehicle coming and moving around and I want to calculate a range fan. So I want to use the speed and the heading to understand like where is it most likely that this thing is going to be next, or what can it see from here? So that's another example of enriching geometry. And then there's incident detection and alerting. And this would include geofencing and things along those lines. One could argue that basically all real-time analysis is fundamentally for this purpose. You may be parsing data, you may be, enriching data and mapping additional attributes onto it, but probably if you're not doing those things just to store the data, you're doing it because fundamentally you want to ask some sort of incident question. And you want to say, has this asset moved in or out of an area of interest? Is it below some critical threshold that I need to be worried about? Is it some combination of those two things, and so forth? So incident detection and alerting is a big part of real-time processing. If you actually need to do analysis in real time, it's because you need to detect something that you need to make a decision on. So within these real-time capabilities of velocity and GeoEvent, users have a visual programming environment to set these things up. And this allows you to kind of have a flexible application of steps to define the process that you want. What we're looking at here is a real-time analytic that is detecting, it's bringing in air quality data, detecting issues, capturing the results, and also actually sending off the data to the simple queue service in AWS so that you could use it downstream in other ways. And in Velocity, users can also use this same sort of authoring environment to configure big data analytics, which again can be run on a schedule. We're not going to get into the big data analytics today, but I just wanted to mention that as an aside. All right, so next we're going to step through an example of putting together one of these real-time analytics, again with Velocity, and we're going to be using that drone data that we set up as a feed in the previous demo. So this is where we left off just a minute ago. We had that drone data arriving in real time to the map. But obviously, typically, we're connecting to a data feed for a reason. We want to know, is some value above or below some critical threshold? Is the data in some area that we don't, or sorry, not the data, but are the assets in some area that we don't want them to be, and so forth. And it's a real-time analytic that allows us to kind of set that up and put it on autopilot. So in this case, I have an area of interest I want to monitor. I have that stored as a feature layer, so I can add that into the map. And obviously, real-time analysis could just be visual. You could just stop at this point and say, okay, I can see visually if any of these, moving entities are near my area of interest or within it. You can certainly do that, but you would have to be constantly, obviously, watching your dashboard and your map, and who has time for that? So again, the real-time analytics are about automating that process. So you can also author those from Velocity. In this case, any real-time analytics starts from a feed, so you have to have data set up and flowing into ArcGIS, and then you can operate it on it in real time. So we're going to select that drone. In this case, it's a simulation, but that drone feed. And that brings it into the designer here. If you're a pro user, you've ever used Model Builder, a lot of this will look familiar to you. Very much visual flowchart programming approach. So with this drone feed, the first thing I want to know about is a critical threshold. I want to understand if the drones are flying too low, because that's maybe a jurisdiction rule that I have for privacy reasons. So we're going to calculate a new field here, actually, to ask that question. And with the field calculations, you can set up one or more field calculations using Arcade. So if you're used to configuring fields or labels in ArcGIS Online or Enterprise, it's the same language. We're going to call this elevation too low, and we're going to set it to be a string field. And certainly the elevation value is something you could symbolize on in a web map if you just want it to visualize things that are too low. But if we use a real-time analytic to calculate this value, that data is then available in other downstream ways if we want to analyze against it easily later. So we'll pop up the Arcade expression builder, and we'll put in this case, a pretty straightforward expression to calculate the sort of a Boolean assessment of the altitude. So if it's less than 100 meters, we're going to say, yes, it's too low. And if it's greater than or equal to 100 meters, we're going to say it's not too low, it's fine. So we'll go ahead and apply that calculation and close the tool. And the other thing that we want to know is whether or not the drone is not just if it's flying too low, but if it's in that area of interest. And so the way that we're going to do that is to pull in that area of interest and use it as a geofence. So in this case, we're connecting to a feature layer. That area of interest is another feature layer in ArcGIS Online. You can also do some configuration as you pull in data through feature layers, like if you want to change fields or set, a subset of the data to be filtered on the way in. We're not doing any of that here, so we'll just go ahead and step through this. But you have basically those same configuration capabilities. I think in this case, we do note that the data has a track ID. So that data is now in the model as a data set that we can use as a geofence. And we're going to ask the proximity question using this tool, detect incidents, which allows you to set criteria to open or close incidents. So with the detect incidents tool, what I want to do is basically do a spatial relationship to understand if the area of interest and the drone are within a distance of each other. And if you had two changing data streams, you could also have a feed going into detect incidents, and you could ask questions between two sets of changing information. So in this case, we're going to ask, again, we're using 100 for everything, I guess, in these examples. We're going to ask if it's within 100 meters of the area of interest. You can set different closing conditions if you want to. And down here at the bottom, you can also set how long an incident should stay open if it stops getting updates. So we're going to say that if we don't get any updates from a drone after 5 minutes, like if we just have, a hang in information in some way, we're going to go ahead and close that incident. If the drone shows up again and it's near the area, it would open a new incident and it would keep progressing. Now, the last thing you need to do for any of these real-time analytics is to define an output of some kind. So there's 3 basic categories of outputs. First, there's ArcGIS outputs. Again, that's the most commonly used thing. But if you wanted to, you could write data out to real-time IoT hubs in Azure or AWS. And if you needed to send an alert, you could do that here. So you can send things through email, you could configure and send things through a text message, or you could actually send things to an external system. HTTP, posting stuff over an HTTP endpoint is one of the most common ways that we see people doing that. So to show what this looks like when it's all done, we're going to go ahead and switch over to a completed analytic here, just to save a little bit of time. And this finalized one is different in a few ways. So it has 3 different outputs, basically. The first one is one that we've labeled as archive, and that's storing all the drone positions over time as they come in. So that's with this newly calculated field. That's an additional step that we have in the model. And then this next output is just the last known position for any drone. So as the data comes in, it's just going to be writing and overwriting the current position so that basically we can have a layer that shows us where all the active drones are at any given time. And that's because sometimes you may want to see the current positions and you may not want to see all the history because it adds up and it can make the map busy. And then this third output is the incidents themselves. So a separate data set just of incidents in case we want to browse incidents one by one. And we can add all 3 of those outputs to a map and show it that way, but to kind of make it a little bit more, kind of show the end point of a lot of this stuff, we went ahead and configured a dashboard so that you can see all this information in context. So the dashboard is showing in the map all the incidents that are currently open. So it's not showing every single drone that's flying around, but just the ones that have passed through that detect incidents where they're close to that area of interest. And the chart at the bottom is showing average elevation by minute. Just you can kind of see if things are, see in that way if things are breaking that critical threshold barrier. And if we were to open one of these incidents, the incident list is on the left-hand panel here. Most of them are ongoing right now, but we'll go ahead and open up a closed one. We're going to see exactly where the drone was during that incident and the full breadcrumb path that the drone was taking while it was over that area. So in this case, it looks like the drone was hovering over a Walmart, and you can kind of see that it's not just passing over it casually, it's kind of hovering over it. So that might be interesting to that company if they were the ones consuming this data for their, situational awareness purposes. So hopefully this kind of just shows how the results of these real-time analytics can be combined into useful information products and really help with understanding the state of the situation that you're monitoring at any given time. So again, that was an example of real-time analytics in Velocity. GeoEvent server is not identical, but it does take a very similar approach. In GeoEvent, you set up what's called a GeoEvent service to process data and perform step-by-step analysis. You configure, instead of calling them tools, like in Velocity, it's very similar to the models in ArcGIS Pro or the rest of ArcGIS, where it's inputs, tools, and outputs. In GeoEvent, there's processors, which transform data, and then there's filters, which filter or ask a question. Overall, the advantage, of course, of these visual programming environments is that you don't necessarily have to be a developer to set up these streaming processes, but there's still a high degree of flexibility in these to capture the automated workflows that you want and to set up rules that define different incident scenarios. Now, in terms of the tools themselves, there's a really wide variety of spatiotemporal analysis tools. In this case, again, this list is specific to velocity, and it includes big data tools and real-time analytic tools. It's also largely the same tools that we talked about yesterday, if you were at the keynote, that are available in the geoanalytics tool family. Velocity and geoanalytics are actually based on the same analytic code base. So the big data analytics that are available in Enterprise and in Pro are available in Velocity as well. Now, when it comes to which tools work in real time, a subset of these work in real time, and that's because not all of these tools make sense to run on every single event as it comes in. So for example, you wouldn't run find hotspots every single time an event comes in. Hotspots runs on a set of data and it's generating an overall pattern for you. So hotspots is something that you would run maybe once every few minutes on a schedule, but it's not something you would run in a streaming way. But the streaming tools include detect incidents, which is what we showed in the example. Also tools for doing movement analysis, like calculating motion statistics, calculating the distance to a given feature that you can join to. We showed the snap to network sort of capability in the keynote yesterday, which is part of GeoAnalytics Engine as well. And in Velocity, you can run that in real time. So as your AVL tracks are coming in, you could be snapping them to a road network so that you create that nice visual on the dashboard that makes it look like things are in the right places, if you will. And the real-time filters and processors in GeoEvent are very similar to these concepts fundamentally. In some cases, they have slightly different names, but the same essentials are there. There's the ability to filter, there's the ability to calculate a field, to do different types of geometric overlays, and to join features and detect incidents. All right, now one thing that we've obviously alluded to a couple times throughout all of this with the real-time analytics is that they can be used to perform alerting. So we'll spend a few minutes sharing a little bit more about that. Alerting, actuation, and collaboration are really fundamental needs for a lot of real-time use cases. We talk about this often as the system of engagement in real-time GIS. You can have something automated and running and on autopilot, but it's, it's probably just collecting data to a layer if it's not actually engaging with your stakeholders and your audience. So that's where the alerting comes in. And this talk today obviously is specific to the server-side technologies in ArcGIS. But I do want to note that there's some other capabilities in the platform for these types of things that you can take advantage of. So many of our field applications have real-time coordination capabilities between field workers and the back office. And things like Workflow Manager, for example, allow you to send an alert when a job has completed or other types of task status situations. So there are a number of ways to alert and actuate within ArcGIS. So as we've covered, real-time analysis fundamentally works off a streaming input. And there's three basic types of output. We went over this in the demo, but just to kind of reiterate, you can send data to layers. And I'm not saying storing data to layers for a reason, so we'll come back to that. You can send a notification of some kind. Typically, we see customers using email and text messages. This allows you to kind of connect to an SMTP server for email, and you can craft a message that you want to send from attributes in the data and send very tailored messages to stakeholders and audience members that you identify. And there's a lot of flexibility here. So you could, for example, when you've derived something that you want to alert on, you could then have another join happening with that output that says, okay, based on what type of thing it is, these are all the people that I would want to actually alert. And then you could send that out as a notification. So you can control the distribution audience as well. And you can even send commands and triggers to external systems. This is, again, probably the least common type of output that we see customers using, but it is supported. And we have examples, I think, of customers using GeoEvent Server in particular to automate work orders being created in CityWorks, for example. So they're an ESRI partner where those types of integrations can be set up. These three main types of outputs are all supported by these output connectors that you see here. There's not as many connectors on the outbound side in these server-side technologies as there is on the ingestion side. And that's really based on demand that we get from users. In a lot of cases, our users are really trying to get data into ArcGIS and get it visualized and get it onto dashboards. And they're not always necessarily trying to route it elsewhere afterwards. So ArcGIS feature layers and notifications tend to be the most common things that people use. Okay, so we're going to round out the discussion today talking a little bit about, in more depth, about visualization and data management. So as I kind of mentioned earlier, we look at visualization for real-time data as a little bit more than just is the latest data on the map. It's in some cases about driving the latest data to the map immediately so that you can see that something's changed. And one of the easiest ways in ArcGIS to show the data on a map in near real time is just to configure a data layer refresh interval in your web map viewer or in ArcGIS Pro. So if you didn't know that that was a capability, it'll be in your layer properties. I believe in ArcGIS Online, you can have a layer refresh as often as every 30 seconds or every minute. So if your data is updating at that sort of cadence, then the layer refresh interval can be the easiest way to do that. And you can do that, obviously, even if you aren't using velocity or geo events at all, but you just have field users collecting data that gets automatically stored to a feature layer, and you have that in a dashboard. You could just put that layer on a refresh interval, and voila, you have near real-time data. So that's actually the most common thing we see people doing, even if they're not using the server-side real-time technology. And then there's also certain client apps in ArcGIS that are really well suited for real-time data. The most obvious one is ArcGIS dashboards, which let you base an entire configurable interface around a web map. And you can configure list widgets that kind of are constantly updating as new features arrive. This example that we're showing in the slide here is actually a widget that is pointing at a URL that has a live camera feed. So there's nothing really in ArcGIS that's parsing that camera feed, but we can just embed that URL in the widget, and then we can get to that, include that data in the same overall picture. And then, as I mentioned in the beginning, there's also the ArcGIS Living Atlas, which has a lot of ready-to-use current data. Often, a lot of that is sort of at the national scale rather than the local scale. But we do have some customers, I think, that have curated more local, like near real-time data sets, and they make that available in the Living Atlas too. And with velocity and geo event, you can send incoming data to layers in a couple ways, as far as driving it to the map in real time a little bit more specifically. It is possible that the computer froze. There we go. All right. All right, so from real-time analytics, we've talked about different kinds of outputs. When you're sending data to layers, there's three basic types of output layers that you can use, depending on your use case and how you want to make that real-time data available to your customers. So on the one hand, you can send data to stream layers. Stream layers visualize new data immediately as it arrives. So it's a very trigger-based sort of thing. What we're looking at in this animation is buses moving around on their routes. Admittedly, we're replaying these buses at a much higher speed. They don't move that fast in real life. At least we hope they don't. But what I'm trying to get at here is that with stream layers, they're often used with point data, admittedly, but it basically just creates this very smooth animation, and you can really kind of see the movement as something is going about. So they can be very useful depending on if you have data coming in more quickly. They are a good choice, for example, with something like the drone data that we've been using as an example, because those do send updates very frequently in the systems that they use. A lot of AVL fleets actually may only update every 30 seconds or every minute. So layer refresh might be the best choice for those. Stream layers are based on WebSocket technology. That's kind of how they have this push characteristic about them. So when you put a stream layer in a web map, your map is fundamentally kind of directly connected to the real-time server. And the real-time server knows about your map, and it's sending the data directly there as it arrives. So there's no latency, or at least there's very little latency. And then, of course, feature layers visualize data from a database. They're obviously the most common type of layer in ArcGIS. But because they visualize data from a database, it has to get into the database first, and then you have to query the database. And so that's where the layer refresh interval comes in. Within the paradigm of what we're talking about today, you'd have data coming in through geo event or velocity. You'd be pushing that data to a feature layer. So it goes through the process, it gets dropped in the feature layer, and the map isn't going to have that point right away. It's only going to have that point once it refreshes that layer. And again, for a lot of use cases, the 30-second or 1-minute refresh is good enough. But just so you know that the feature layer isn't dynamically at every single moment showing you the latest data. It's only once you move the map or once you refresh the map, which again, often enough. And then when you create a feature layer in ArcGIS Velocity or with GeoEvent, with Velocity, it's automatic, and with GeoEvent, you can choose this, but you can also create a special type of map image layer that will show you, it's very good for when you're storing observations over time and you build up high volumes of data. This basically supports dynamic aggregation. So what you're seeing in this animation is as we zoom in, we're seeing this on-the-fly heat map, and it's drawing the data at different size bins at different levels of the map until it automatically transitions over to raw data. And it transitions over to raw data, which it's doing right there, when you have a small enough number of features in the map extent so that you're not bringing too much data directly into the map. So all three of these can be created through the analysis configuration experiences that we've been showing, and they can then be used across ArcGIS maps and dashboards and client applications to visualize this information. Now, data management is another very important aspect when you're dealing with real-time data, and it's not necessarily the most exciting, which is why I've saved it for last, but it is a really critical piece to plan for and to consider when you're doing a real-time implementation. So data that comes in real time fundamentally exerts constant pressure on your database when you're storing the data, and most of the time, of course, we do want to store the data. So because of that constant pressure that it exerts on your database, typically, depending on the rate of the data, you might need a beefier database to keep up with that level of flow. And so the spatiotemporal data store is an additional kind of managed data store that's available within ArcGIS Enterprise for these kinds of scenarios. You can pair it with GeoEvent Server, and it's part of the overall package with ArcGIS Velocity. We don't talk about it as a separate component because it just comes with it. And the spatiotemporal data store supports a couple key things. On the one hand, it lets you bring in data at higher rates than you probably could with the ArcGIS relational data store. And it also allows you to store higher volumes of data, which is important as data is constantly coming in real time. And it does this because it spreads data out over multiple nodes. You can, when you're using ArcGIS Enterprise, you can install this data store on one node, but we really recommend you use 3. And that allows it to spread data out, and it creates replicas, and that provides resiliency. So if you have, a node go down, you can still draw your map and you can still get to your data. And the high volume storage is often needed because data adds up really fast in real time. So if you're bringing in data to a feature layer, let's say 100 events a second, that actually adds up to over 8 million features a day. And that may not, 100 events a second may or may not sound like a lot to you. I think in a lot of cases when I talk to customers, 100 just sounds like a small number, but when it's every second of every day, it obviously adds up quickly. And that may also sound like a lot to you. It may be a lot more than the real-time data sets that you guys experience, but we do have some customers for whom that's actually low, and they're bringing in data at thousands of events per second. So this gets unwieldy really, really quickly unless you plan for it. And it's important to consider how often you want to keep that data around. So the spatiotemporal big data store has these concepts of data retention and archiving that are associated with it. And these concepts tend to be more important with real-time and big data workflows than otherwise with other things. So when you're using, when you're configuring output feature layers, I should say with Velocity, you basically always select the data retention property for that layer. Unless you're running like a one-time analytic that's creating an output, if you're configuring something in real time, you always have to choose the data retention. And then the archiving is built into it. And in GeoEvent, the archiving is something you can choose to do at your own cadence, basically. And then the other key aspect of the spatiotemporal big data store, as you bring in this data and it accumulates to high volumes, is that it indexes data as it's stored, both spatially and temporally. And that is what is enabling these on-the-fly aggregation visualizations that I was talking about. So it's the same animation here that we were showing before. But the reason that this happens and the reason that it can be useful to deal with high volume data is because the data is being indexed as it's written to this big data store. And there's a map service that is drawing the data on the server in these aggregations until you get down to an area that has a small enough number of features that you can extract the actual features. So this tends to also be an advantage for your users and the client apps that they're using, because you won't necessarily have the same degree of slowness that you would have if you're trying to draw hundreds of thousands or millions of points, just raw data on the map. So some things to think about in terms of dealing with real-time data and how much data load you have, how much data you expect to keep, and what kind of experience you want your users to have in their applications. All right, so to wrap up for today, Velocity and GeoEvent in many ways are two sides of the same coin in ArcGIS. They're server-side technology that are very agnostic, and they let you connect to almost any kind of tabular or vector data to parse it and to make it available within ArcGIS. And there's, as we've covered, there's different visualization options. There's different analytic tools that you can perform to adapt the data as it comes in. And those analytics at the same time can enable you to do incident detection and geofencing if you actually need to drive results proactively to stakeholders. For Velocity, if you're wondering why we're talking about two different things that have two different names and do the same thing, there are some reasons why these are different products. So Velocity is essentially our software as a service real-time product, and it's a part of ArcGIS Online. And it is different than GeoEvent because it is based on different technology in the back end, and because it does have some different capabilities. It includes big data analytics as part of it, which is not part of GeoEvent in its base deployment. So that's one of the reasons why it's a different product. And because of the technology it's based on, it supports higher velocity data and workflows. It runs on Kubernetes in the back end, and you can actually scale out feeds or real-time analytics for the data that's coming in, and that happens kind of fluidly for you. Because it's software as a service, it's certainly got less maintenance for customers. So if you don't have a large IT department and the ability to kind of configure and set things up yourself, then Velocity may be interesting and useful for you. GeoEvent, on the other hand, is our enterprise real-time server role. So it's the main thing within ArcGIS Enterprise that handles these types of workflows. And it supports storing and visualizing big data. But if you wanted to do analytics on that big data after it's collected, you would pair GeoEvent with GeoAnalytics Server, and you would use those two things together. GeoEvent's also pretty much single server technology, and that's because we have a lot of customers that they don't want the complexity of scaling something out across multiple machines, and distributing real-time data across multiple machines in kind of the older architectures is tricky. So GeoEvent is really single server architecture, and as such, you're only going to get a certain amount of data velocity and performance out of that. So what we say in general is that GeoEvent is better for lower velocities of data than ArcGIS Velocity is. And then on the flip side, GeoEvent does have more flexibility in terms of its configuration. It's also extensible. So if you really, really need to dig in and customize your deployment, and you have an IT staff that wants to have that degree of control and maintenance, then GeoEvent can be a good solution for you. But either way, depending on whether you need to use enterprise or online, basically either product allows you to take advantage of this flexible data ingestion and these automated analyses to work with data. In many ways, we think of GeoEvent and Velocity as these underlying real-time engines, if you will. They're often not necessarily at the forefront. What they do is they run, they automate, and they produce data into layers. And then those layers are typically what you're serving out and making available to your stakeholders and to your users for situational awareness. There we go. All right, so I just wanted to encourage you guys, if you're interested in learning more about these, we have, as with other things, a lot of great information on our website. Both products have extremely extensive documentation, tutorials. They both have pretty active communities, and the product teams are always monitoring those communities, so you can get on there and ask questions about how to do something. And those communities also have lots of little tips and tricks, like, oh, here's how you set up this connector to talk to this API or that API. So if there's a lot of common data vendor APIs that we provide examples for in the communities. And so definitely recommend checking some of that stuff out, or come talking to us afterwards today if you want to learn more. And with that, we can go ahead and take any questions. And if we have questions in the from the online audience, then I can repeat those or pull up the chat. Maybe they'll ask now, since we're open for questions. Oh, you don't have the chat? No. Don't see any questions? Okay. Yeah. So the question was, does Snap to Network work in both products or just in Velocity? And that one I think is only available in Velocity. Other questions? I guess I answered all of the questions. I anticipated your every need. All right. Well, thank you guys very much. Come see me if you want to chat offline, and appreciate your time.